So my name is Brad Hayes. I'm the CTO at Circadence. I'm also an assistant professor of computer science at the University of Colorado Boulder, where I direct the Collaborative AI and Robotics Lab. So there are a lot of companies trying to put robots into people's homes, and the problem really is that this is incredibly difficult. I do think that we will be seeing robots entering our homes, but I do think some of the first applications that we'll encounter are more in the lines of assistive devices, so robot prostheses and maybe even wheelchair-mounted robots that can help give people back dexterity or just capability that they might have either lost or never had. And so it really depends on what you want out of that robot. So the nature of the interaction characterizes people's expectations in the capabilities of that system. So how are people going to want to interact with, say, this chat agent or this robot? What's the purpose of this agent or robot? So recently Google did a technology demo where their autonomous system called a hair salon, made an appointment using a synthesized voice that sounded very realistic, interpreted the voice from the other side of the phone and responded to the questions appropriately, and actually set up a real appointment with a real person, and that person had no idea that they were talking to a machine. But one of the reasons why that worked so well is because the process of making an appointment at a hair salon is very structured. And so you don't have to take into account all kinds of other things that might come up. You don't really have to take into account small talk. And so that's one of the reasons why it's important to study, is because it's not immediately clear at all that any of the research on human-human interaction is going to apply to human automation interactions. And one of my favorite examples, we had an experiment at the lab that I did my PhD in, where we had people play rock, paper, scissors with a humanoid robot. The experiment was to see what effect the robot's behavior had on perceptions of agency, which is to say that if the robot cheated, how is that going to affect somebody's perception of its capability? If the robot lost the game but just said, "I win," people assumed it was broken, and their responses generally went down. They thought less of this system. But if they both threw their gesture, if the robot changed its gesture and then said, "I win," people thought this robot was really intelligent. People started talking to the robot, right? So even though it was clearly just playing some pre-canned audio, all of a sudden people scaffolded this whole capability framework of, well, if it knows how to cheat, it must know how to do all of these other things. And so those effects are really interesting to us because they tell us something about how we perceive this sort of hierarchy of intelligence and capability, and helps us structure the interaction, or what capability we try to project from the systems we build. This is one of the things that I'm most excited about, which is a lot of the problems that we're trying to tackle in the human-robot collaboration space are also echoed within the cybersecurity space. So there are these shared components where if you're trying to do any kind of collaborative exercise, you're trying to infer the intent of others. And in this case, in the cybersecurity case, you're still trying to infer intent, but both on the adversary side and on your side. And so if you see somebody doing something on your system, we're still trying to solve that inference problem. What's their goal with this? Where are they trying to go with this? Why are they doing these things right now? Or what do I think they're looking for if I see some kind of meandering pattern? And so in the human-robot collaboration domain, we would identify that goal and then perhaps execute something to assist the person in achieving that goal. Whereas in the cybersecurity domain, you might imagine in a defensive capability, if we can assess what somebody's intent is or what their goal is, then we can proactively take steps to mitigate that so that they can't achieve their goal.